All right, here is a review of the practice test that I gave you. I hope a lot of people watch this and it helps a lot. Um, Here we go. Maximum time allowed for the completion of a midterm examination. So this is one of those, do you know your space, your place in space type of question. Can you approximate things? Usually it's related to size or mass. If it's size, a hint is use your ruler that you're going to be given. If it's mass, compare it to something that you know. Some things that you know are 1 kilogram is about 2 pounds. In terms of length, 1 yard is equal to 1 meter. For this question, though, they just want to know, can you convert actually? They're giving you the answer. It's 3 hours, but it's in terms of seconds. So to go between hours and seconds, 3 hours times 60 minutes per hour times 60 seconds per minute. The minutes go, the hours go, and you're left with some number of seconds, whatever 3 times 3600 is. It's going to be a little more than 1, but that doesn't really, a little more than 1 times 10 to the something. It's if it was 3300, it would be 10,000. So let's say it's 10,000. That means it's 1 times 10 to the 4th, which this question's also asking you about scientific notation. Can you do that? I'm not going to teach you how to do that. You should be able to do that. Second question, this graph, look at it. Velocity versus time. They're all linear. The slope is important. The slope is equal to the acceleration. Now we read the question. Which has the greatest acceleration during the time interval 10 to 15? So they're looking at this interval. The greatest slope is the greatest acceleration. So it looks like D is the right answer to that one. I know it sounds silly or simple, but you have to look and see what's plotted versus what first, and then figure out what the meaning of the slope is. This is actually a graph where the area means something too. The area underneath a curve, pick a curve, I don't care which one, the area represents the distance. Well, actually it's the displacement. If it's all positive, it's distance, but if it goes to the negative side, then it would represent displacement because you could subtract that out. Next question, you have a force to the left and a force to the right, and there's no friction, and it says, what is the magnitude if it establishes equilibrium? Equilibrium is a huge concept. It means F net is 0. Also means A is 0. It means V could be 0 or V could be constant. So you'll have to decide which one, might be necessary in a question. You might read a question where it says V is constant in the wording, so you have to know this is true and you have to know this is true. If I erase these guys so I can actually read the question, what's the value of F have to be to produce equilibrium? This force right here can be broken into 2 parts, that one and that one. The weight of this will balance out this force. It's not going to be lifted up in the air. It's sliding horizontally, I believe, or trying to slide it horizontally. So really what you're balancing is this horizontal force and this horizontal force. This one's unknown. This one we know because it's the x component of this, so it's 100 times the cosine of 30 degrees, which I think is 0.866. So your answer would be 86.6 newtons, 0.866 times the 100. All right, next question. Approximately how far will an object near Earth's surface fall in 3 seconds? So you want to know delta or dy, v initial yt plus 1/2 ayt squared. How do I know this equation? Well, I want to know d, that's how far. It's near Earth's surface, so I know ay is g, or 9.8. It doesn't say about initial velocity. You can assume it's 0 in this question, although it really should say that, because think about it, if it fell from 0, it's going to fall a certain distance in 3 seconds. But if it had already fallen and you have some initial velocity, it's going to fall a lot farther in 3 seconds. That's basically what this graph shows, right, for accelerated motion. So really this is an invalid question. bad. But let's assume that this is 0. So dy equals 1/2 negative 9.8 3 seconds squared. So 9 times 10 is 90 times a half, about 45. Is that one of the answers? Yeah, it's 44. It would be negative here, but all that does is mean that it's falling. All right, next question. A 5 Newton force directed east and a 5 Newton force directed north act concurrently. That means at the same time. Time and place, the equivalent of the two forces. So you have a force of 5 east and 5 north. The resultant is this one, which is 5 squared plus 5 squared square rooted, but they want the equilibrium, and the definition of the equilibrium is the force that would put this into equilibrium. So if I had a force in this direction of equal magnitude but opposite direction of the resultant, that would produce equilibrium. So the equilibrium is whatever radical 50 is, which is a little more than 7, right? Because 49 is 7 squared. And it would be, this would be west and south, so the opposite of northeast. So I believe 4 is the answer. All right, let's erase and do some more really quickly, see if we can get this first page done in under 10 minutes. And how many possible components can a single force be resolved? This we talked about once or twice in class. I think there was a question on this. Normally we break it into 1, 2, X and Y components. But you can break this into whatever you want. That's a bad picture, but all of these individual vectors, you could break it into those if you wanted to. So unlimited number is the correct answer. Graph below represents the relationship between force and acceleration. So that relationship is F equals ma. The slope would be equal to a. Right before I even do this, excuse me, slope would be m. Great, I can't read. So right, because F over a is equal to m, so delta F over delta a is the slope. So the mass would just be the slope. So pick your favorite point. This one right here and 0 seem good to me. So 1 is my delta F and 2 is my delta X or my delta A. So it would be 1/2. So it would be that. Or you could just pick a point and plug it into the F equals ma equation. Because it's linear, any point's going to work. All right, question 8. 2 cars having different weights, so different FG. FG1 is not equal to FG2, are traveling on a so that means their masses. M1 is not equal to M2. Are traveling at different constant velocities. So V1 is not equal to V2. Within the same time interval, the greater force will always be required to stop the car that has the greater. So force is equal to ma. And because we're dealing with velocities, we can change this to m delta v over delta t. So the greater force is going to be required for the car that has the greater m delta v. I'm assuming that the time, within the same time interval. So time doesn't matter, so it's just m delta v combined. So you can't say it's m, you can't say it's just v, you have to say it's the combination of those two, which you guys should know that m and v together is the momentum. All right, last question. What is the magnitude of the gravitational force between two 5 kilogram masses separated by a distance of 5 meters? The gravitational force is g m1 m2 over r squared. So it's g times 5 kilograms times 5 kilograms divided by 5 meters squared. Basically, these are going to cancel out, right? 5 times 5 and 5 times 5. So your answer is G. So 6.67 times 10 to the negative 11.